Hi to all. Welcome to srinivasphysicsclasses. Till now, if you not subscribe my channel, subscribe and share to your friends, comment and like. Now I am going to start the Biot savart law applications. In the previous class we discussed about the Biot savart law. That applications now I am going to explain. Okay, and how to apply this Biot savart law at various locations. Now let us see what is Biot savart law first. This is a current carrying wire, okay, and it carries some current I. On this let us take the small element whose length is dl. Now this is said to be current element, okay, and from the element at a distance small r, if you want to find out the magnetic induction, that is dB, then the dB formula is the magnetic induction due to current element, that is ideal sin theta by r square, that is nu naught by 4 pi into ideal sin theta by r square. This is the formula to find out the magnetic induction due to current element. Now the first application I am going to give, this is the Biot savart law. Now first application I am going to give, that is a magnetic induction at the center of current carrying loop. Then how to find out the magnetic induction at the center of current carrying loop? This is the current carrying loop, it carries I current. Then on that I am taking the small element whose length is dl. Look at here, in the red color it is there. This is the small element, this is the small element, and whose length is dl. And now from that element at a distance small r, this is the small r, but the small r is equal to here capital R. At a smaller distance at the center of the loop I want to find out the magnetic induction. Okay, first I will find out the magnetic induction due to this small element, okay, and the latter due to this total circular current carrying loop I will find out the magnetic induction. My aim is to find out the magnetic induction at the center of current carrying loop. This is the current carrying loop and at the center I want to find out the magnetic induction. Okay, first you have to find out the magnetic induction due to small element. If you integrate that one, then you will get the total magnetic induction. Then what is the magnetic induction due to small element? The formula for the magnetic induction due to small element according to Biot savart law, we know that nu naught by 4 pi into ideal sin theta by r square. This is the formula, right? This already you know. Okay, and according to Biot savart law, this is the formula, that is nu naught by 4 pi into ideal sin theta by r square, right? R square. Okay, now this is the formula based on Biot savart law, that is the magnetic induction due to current element of length dl. Now let us see in this, what is theta? Theta is the angle between the dl and r. R is what? R is the distance of point where we are finding the magnetic induction from the element. But here in the figure, from figure we write, this is small r perpendicular to dl, radius is always perpendicular to the arc, okay, r perpendicular to dl we write, that means theta we will get as 90 degree, and one more point also we write, the small r is the distance of point where we are finding the b from the element. This is equal to radius of the circle, but the radius we are considering as capital R. Then these two conditions we substitute in above equation, then we will get the formula as dB is equal to, okay, dB is equal to nu naught by 4 pi into I dl sin theta. Okay, what is dl at here? dl is a small element. I dl sin theta is 90, sin 90 by small r is capital R square we write. Okay, now we have to simplify what we did it in this. In small r is replaced with capital R and theta is replaced with 90. What is sin 90? Sin 90 value already we know, that is 1, right? Now let us substitute in that. If we substitute these small r value capital R and theta 90 degree in this equation, then we will get like this. Let us see here, I will write by substituting that values, and now look at here, this was very simple and interesting, and that is dB is equal to, we will get as mu naught by 4 pi into I dl sin 90. Sin 90 value is 1, right? And here we were getting this equation. Let us simplify this. And now mu naught by 4 pi into I dl by, we will get as capital R square. Let us consider this is equation 1. Now this is the magnetic induction due to element of length dl. Due to small element magnetic induction we find out, but due to this circular loop, right, I want to find out the magnetic induction at the center. For that, this is a small element. Due to small element magnetic induction dB, like that there are many small elements are there. Due to every element the magnetic induction is there. Then if you add the magnetic inductions due to all elements, we will get the total magnetic induction due to current loop. That means now instead of adding, we can do the integration. That is magnetic induction due to current loop, right? Magnetic induction due to current loop. Magnetic induction at the center of current loop, right? Magnetic induction at the center of current loop. How we will get? At the center of current loop. Okay? Right. Then total magnetic induction I want. Total, right? Total magnetic induction due to current loop, that is B. The total we will get just by integration, right? Integration of small magnetic induction gives the total magnetic induction. Instead of summation we will use the integration term instead of summation. Okay, now here we substitute this integration. dB is what at here, mu naught by 4 pi into IDL by capital R square. Right, here some constants we can write outside. Okay, this we are writing from equation 1. Let us write some constants outside. What are the constants? Mu naught is the permeability of free space by 4 pi is a constant. Capital R is the radius of the circle, that is also constant, right? Now we will get as I also we can consider as constant. Then we will get integration dl, right? Integration dl. dl is what is length of small element on current loop. Integration dl gives the total length, right? Total length what it is? Integration dl formula is there, right? Integration dl is total length. That is total length we will get as integration dl is, right? dl is a small element on the loop. Integration dl is the total length of the loop. Total length of the loop is equal to perimeter or circumference, that is equal to 2 pi r. We substitute here integration dl is 2 pi capital R. Now something will be constant, cancel it here, right? What it will be cancel? In this pi will cancel and 2 2 will cancel, right? And 1 r and square will cancel. The remaining is what? What's remaining it here? The formula for the magnetic induction at the center we will get as mu naught I by, we will get as 2 r, right? 1 r remains it here and 2 remains. This is the formula for the magnetic induction at the center of current loop. Okay, right. Now here the magnetic induction at the center of current loop depends upon the current and radius. That is the B directly proportional to current and B directly proportional, inversely proportional to radius. But hey, this is the magnetic induction due to only current loop. But I want the magnetic induction due to coil if you want. Okay, magnetic induction at the center of circular current carrying coil, of n turns, right? This is the magnetic induction due to only one turn. Loop means only one turn. If n turns are there like this, there are some turns are there, right? Then what is the magnetic induction at the center? It is carrying some current, let us consider. Okay, the other moment magnetic induction formula is what? At the center. Okay, that formula is magnetic induction is equal to nu naught Ni by 2R, right? Nu naught Ni by 2R. This is the magnetic induction at the center of coil, right? Okay, magnetic induction at the center of coil is nu naught Ni by R. That means n terms will be there. Okay, n is what here? N is the number of turns. N is the number of turns. Okay, and this is the first application. There is a magnetic induction at the center of current carrying loop we can find out, and current carrying coil we can find out by using Biot savart law, right? Biot savart law is useful to find out the magnetic induction due to current loop. Now let us continue this. I am going to rub the board and I will continue. Okay, let us continue. Previously we derived the formula for the magnetic induction at the center of current carrying coil or the loop. Then what you got? That you got as B is equal to, we got magnetic induction formula mu naught Ni by 2R. This formula we derived. The magnetic induction at the center of current carrying coil which has n turns. Okay, on what factors the magnetic induction depends? That is depends upon the number of turns, and the magnetic induction proportional to the current, and magnetic induction inversely proportional to the radius, right? These are the factors on which the magnetic induction depends. Now I am going to give continuation, right? I am going to explain the continuation. Current carrying coil, around the current carrying coil, magnetic field will be produces. That coil will act as a magnet. That coil will act as a magnet. Now see here, when it acts as a magnet, let us see, it should have the north and south poles. Okay, it should have the north and south poles. Then for the current carrying coil, to know the poles, which face will, the coil has the two faces. For example, this is a coil or the loop. Loop means only one turn. Coil means there are many turns are there, turns. Okay, the wire is wound into many turns means that is called as coil. If wire has only one turn, right, like this, if you make like this, for example, this is, you are making like this is only one turn, right, and that is said to be loop. And if you make many turns, then it will become coil, right? Now let us see how to know the phase, which phase will act as north and which phase will act as south. For that we have to use the Clockface rule. Clockface rule. Okay, look at here. In that Clockface rule, for example, anything, for example, you are watching it here, my fingers, and now, for example, I gave like this. Okay, and now I gave the arrow marks like this. Okay, and like this, I gave the arrow marks, right? And if the face of the coil, there are two faces are there. If one face on the one side it appears as clockwise, then if you see the same face from the other side, that will appear as anti-clockwise. Okay, for one face of the coil. Okay, from, for example, you are looking this face. Okay, coil face from this side. The current is going like this, like this, like this, like this, like this. Right? That means current is appearing as clockwise from this face. But if the same, if you observe from other side, right, that will appear as anti-clockwise. Okay, that will appear as anti-clockwise. That means one face, the face in which current appears as clockwise, that will act as a south pole. Look at here, how it will act as south pole. Current appears in this as a clockwise direction. Okay, I am telling that the current carrying coil act as a magnet. That means it should have the north and south poles. Then which face of the coil act as south and which face of the coil act as north? To know that, we have the Clockface rule. According to the Clockface rule, if the current in a coil appears as clockwise, okay, on one face, if the current appears as clockwise, then such face will act as south pole. What I am giving here, if the current is in clockwise direction, then the magnetic field produced is normally inward, field is inward, and the face of that coil act as south pole. look at here, the current is in clockwise, this phase will act as south pole. Look at here, south, here this arrow also indicates the clockwise, right? This is the south pole. And here we are telling that the magnetic field is inward. This we have to use the right hand thumb rule. According to the right hand thumb rule, right, you have to thumb shows the current, curled finger shows the field. But curled fingers maybe shows the current, thumb shows the field. Look at here, these curled fingers are in circle, right, like this. They are showing the current in clockwise and the field is inward, right? If you show like this, then look at here, current, curled fingers are current, but current is not like this, right? Current is not anti-clockwise. We cannot show like this. We have to show like this. That means the field is inward. Current shown by the curled fingers and field shown by the thumb. Thumb is inward. That means the field is inward. The field is inward and the phase will act as a south. And if the current is in anti-clockwise direction, look at here, one phase, right? On one side if it appears as clockwise, on the other side it will appear as anti-clockwise. If the current in one phase appears as anti-clockwise direction, then that phase will act as north pole. Look at here, arrow mark is like this there, like anti-clockwise. That phase will act as north pole. And like this, when the current passes through one coil and one phase will act as north and other phase will act as south, and the current carrying coil behaves like a magnet. For example, you have the like this current carrying coil, right? One phase will act as north and other phase will act as south. Like this, current carrying coil behaves like a magnet, right? And the clock phase rule we have to use to know the south and north poles, right? And now here we are telling that in anti-clockwise direction the field is outward. Look at here, curled fingers indicates the current. Okay, current is like this there, anti-clockwise, and the thumb indicates the field. Magnetic field is outward, right? This is the thumb rule we have to use. And the magnetic field pattern due to circular current carrying loop. Okay, field lines how they are there. Okay, field lines how they are there means the field, this one. Okay, look at here, this is the pattern. The field lines will be like this there. Okay, the face, upper face will act as north, like this we are telling the field. Okay, field is upward, field is upward. Okay, this is the current carrying coil, the field is upward, that's why all the arrow marks are in upward direction. This is the magnetic field pattern due to current carrying loop. In 1 mark question they may ask to draw the field lines. Okay, right. And now